Hello everyone and welcome back to another video. So today we're gonna talk about some I guess rather complicated things for if you're a beginner, but not really that complicated things for when you already know this mod. So I've been mentioning in the last couple of videos about my Tahiti based cards, so this GPU core that you can on AMD cards, on older AMD cards. I think it works up to the RX 590. I think it stops working with Vega and everything that comes after that. So yeah, on AMD cards you can modify the memory timing straps to get more performance. And basically what I've done here with this card, because this has the best memory of all my Tahiti cards, I have tested a lot of different memory straps, even some custom straps that I found their way to me. And basically, what I'm gonna do in this video, I'm gonna show a very nice spreadsheet, and we're gonna go into which strap performed the best. And the custom straps, I'm also gonna hopefully link in the description. If I forget to link them in the description, please complain very loudly in the comments and I will link them to you there. Because, well, spoiler alert, one of the custom ones is the best, by far. So, yeah. I do have to say as a disclaimer, this is for this specific memory chip. Well, you can see it better on this one, while it's, you can see it well on this one. So, these memory chips are SK Hynix 2 gigabit AFR modules. If you do not have these memory chips, the straps I'm using here will likely not work, and if they work, you might see some very different results. Like I've never personally tested a Samsung-based Tahiti card. I've also never tested an Elpida-based Tahiti card. I've only tested AFR modules and MFR modules. And basically the short version is MFR doesn't clock as high and also not as good of timings, like it doesn't handle the timings as well. Yeah, but I do have 2 gigabit AFR on this card and also my 7970 matrix, which it's kinda weird. Like this is called R9280X, this is called HD7970. They're actually both the same cards. Because like the core on these is the same, and this one also has the exact same memory chips. Though the memory chips on this one don't clock as high. Though that might be because I never overvolted these. I've overvolted these to 1.7. These are at stock. I don't actually know, like stock might be 1.5 or 1.6. Could be but like in my testing, these the memory chips on these cards, they ran the same timing straps, but at a couple megahertz less. So yeah. And if you're not asking yourself how you do that mod, like it's a BIOS mod, you have to use a hex editor to make a custom BIOS. I'm gonna be looking into making a tutorial for that. But today we're just going over results for this here card. And I gotta say, you kind of see it from the results. You can gain a lot of performance and benchmark score from this. Like basically this and turning tessellation off are the biggest performance boosts. And I think this memory timing mod is basically what brought me to like, I'm 10th for 7970s on HWBot right now. I'm 4th for R9280Xs thanks to this card. And I'm 3rd for 7950s, I think. I do not have a normal 280. But if I get one, I guess I could take a very good spot on that one as well. So yeah, this memory timing mod is quite literally overpowered, and I would very much suggest you do it as well. But what is it gonna do for you? Well, let's take a look at the results. So here we are. Here's the results for the PowerColor R9280X memory strap testing. Yeah, I was running the card 1250 megahertz because at some point you do run into bottlenecks where you don't really gain more memory bandwidth without raising the core frequency. And here again is the full part number of the memory modules that this actually applies for. So I've done 2 tests. The first one, which is actually the lower one, is the stock memory strap. So here I've only used the memory straps already present in the BIOS that the card comes with stock. And then the modded timing strap is where I took some timings for this memory chip that were sort of custom made. And I tested those as well. So yeah, let's first go into the stock one, because that's the basic version of this mod. Like, you just, like, there's gonna be a more detailed description in the guide to how to do this, but essentially what it is, you go into the BIOS, you take a memory strap for a lower frequency and apply that timing strap to higher frequencies as well. So basically you're running 1750 megahertz, but you're still using 1250 megahertz timings. And you can see there's a couple steps after 1250 where new timings would apply, but you essentially disable that. So I've tested timing straps all the way from 1125 all the way to stock. Stock means just 1750, because that's the highest clock where new timings apply. After that it doesn't change anymore. And yeah, so then here in this column we have the maximum memory frequency I was able to reach, and then here we have the maximum memory bandwidth that I was able to reach at that frequency. Now I tested the memory bandwidth with OCL membench, so yeah. This looks kinda stupid, but yeah. Usually I would do this on the tablet, but I'm on my desktop right now, so I only have the mouse. Yeah, so OCL membench. It's a little program, you run it, it does a couple tests. I took the highest value, like it does like 24 tests, and of those 24 tests I took the highest bandwidth that it was displaying. So yeah, that's how those numbers are made. And yeah, so let's just kind of review the results. So 1125 memory strap, you don't really want to bother. The maximum memory frequency I was able to reach is 300 megahertz lower than what I'm getting at stock, which means this kind of sucks. The maximum memory frequency is actually better, but basically the mod is not worth doing if you lose a lot of frequency. And 100 megahertz I think is okay. More than 200, like even 200 itself is, you really would have to then test, like at 200 you still might get a higher score even if you're losing 200 megahertz, but at 300 megahertz, like, yeah, like, I mean 245 is better than stock, but like that, we're gonna get to that. So 1250 is what I ran for my current best score on HW board. I actually made a better score. That's about 200 points better, but I haven't uploaded that one. Also the first place, like worldwide first place for 280Xs, made by Salty. He was also using 1250 timings, and he also has this exact memory chip on his 280X. And you can see this has really decent results. But we can do better actually. Now that I've done this testing, we can actually see, oh, we can actually do better. Because for a long time, like 1250 mem timings, you are not able to run 1250 on, say, MFR. Like this is AFR, but MFR, which is on some older 1080 based cards, actually can't run 1250, not in my testing, without losing a lot of frequency again. But AFR is, like, you're only losing 200 megahertz, which is like in the range where you would do some testing, and it was scoring pretty well. Then again, that better score I did with this, and you can kind of see, yeah, that's where it's coming from. But this was scoring quite decently. But now we know that 1375, which is the same timing strap I ended up running on MFR, is actually even better, because you get more bandwidth and you actually get back up to your maximum clock, at least on this card. I have to say at this point that if you're like, this is OCL membench, it's nowhere near as heavy as like running a proper benchmark. Because it does 2000 here doesn't mean it's gonna do 2000 in like Firestrike. But you should be rather close. Because for example here I was maxing at 1900 in OCL. I was passing Firestrike at 1860. So that 40 megahertz, that's like not that bad. But yeah, this is mostly just to compare like memory bandwidth with like different timing straps, not like maximum frequency you can reach, because like yeah, in actual like well, actually testing your frequency is gonna be somewhat lower than what OCL membench tops out at here. But basically what we're seeing for the stock memory straps, 1375 is the sweet spot. You get to the highest frequency, like 2100 just straight up doesn't run on my card. It just vaults at 2000, it doesn't go any higher. And this is basically the strap that gives you the most memory bandwidth on the card, because like we're reaching 2000, we can't go any higher frequency, and loosening out the timings is not gonna help us. Like you see, we're losing very little going 1500 timings, but we're kind of losing a lot going to 1625, and then losing a little bit more when going to 1750 or just straight up stock. So 1375, if you have an AFR card and you don't want to bother with like doing custom timings, I suggest you just use the 1375 timing preset. You see it's still kind of pretty close to the maximum that I was able to achieve here. So yeah, 1375 pretty much the sweet spot. And yeah, then 50, like I think we can pretty much just skip these, because like they wall at the same frequency, because now I'm not bound by, like basically there's just a maximum frequency that this chip can do regardless of timings, and it's just that this is the point where you get to that maximum frequency, and anything after that is just loosening out the timings, essentially reducing performance, which we can see in the results. So I guess we can skip that and now go to the modded memory straps. Now you can see the values are slightly different here, because those straps, like even from card to card, the straps you have can change. Like not every card has a 1625 strap, not every card has an 1125 strap. Usually they have 1250 and 1375, and usually also 1500, but the other straps, like also the 1750 strap, isn't always there. On some really old cards it only goes to 1500 and not further than that. So yeah, and these straps are like for basically from a card, or specifically engineered to, like, because they're custom, to run some slightly different frequencies. What I did, I just pasted them there. Like I didn't change the frequency that the card changes timings at. I just, yeah, like basically I just, like, except for this result, which is, you can pretty much ignore the all -4 result, because it's just the same as this, just with some slightly more tweaked timings for slower frequencies, but you're gonna be running at your maximum frequency for benchmarks anyway, and they are literally exactly the same because I'm running the same strap for that. So just basically ignore this, like, ignore this result. It's unimportant. I was just testing something, and it, like, I mean, yeah, it does better at lower frequencies, but why would you care? So just kind of ignore that. So yeah, so the first strap was meant for 1000, and well, the card kind of artifacted on Windows login screen, so this didn't run at all. Those were really tight timings, like for 1 gigahertz, and like I was maxing at literally double that, so can't really expect that to work. 1375 worked though, even though very briefly. Only 1500, which is stock speed for this card, and the result is also kind of, compared to stock, it's, yeah, not very much better. 1550, we get to 1700, which is kind of close what we did at 1250, but still kind of low. Performance is the same as 1125, but yeah, it's still not that great. Then 1700. And this is the one. This is the one I would suggest you run, because we get to 1900. That's higher than our 1250 straps. And we're actually getting, if you look at 1800, We're getting 255 at 1800 with 1250 straps. We're getting 263 at 1800. So with the custom 1700 strap, we can clock higher than with the 1250 strap and actually get better performance than with the 1250 strap. And then, because we can go higher frequency, I was able to pass at 1900, and that's how we got the highest result, pretty much by a lot. Like the next highest is this one. So yeah, that's kind of a lot. So this custom 1700 strap it's just the best. So I'm just gonna clean up some stuff. So yeah, this is the one you wanna be running, because you're only losing 100 megahertz of the maximum frequency of this chip, and you're gaining so much performance. Like, look at that, 277 versus 232 stock. What's that in percent? Let me type that out on my smartphone. Like, I'm bad at math, so I need a calculator for everything. Yeah, that's a clean 19.39%. Like, essentially 20% more performance. Just by messing with memory timings a bit. Like, that's what we like to see. That's where the big scores are. Like, I don't think turning off tessellation gives you like 20%. So this is really damn good. And the thing is, this is basically a get into top 5 for, well, I mean, okay, 7970 ranking is very competitive, so basically get into top 10 for free card. Because it's just, this is, like, not a lot of people are running modded memory timings in the first place. And of all those who are running modded memory timings, I think only a very, very select few are actually running custom timings like I've tested here. And you can see, like, we can still gain a nice amount over just using memory timings the card came with and applying them to higher clocks. So yeah, this is really amazing. Like, this is really good. Then the next strap, it didn't have an 1800 strap, it just went to 1900. I was able to get 2 GHz working again, but performance plummeted. Like, it's still high, it's by 1 higher than the highest I was able to achieve at stock straps. But basically, yeah, like, performance drops off again. You want to run 1700. And then this again, like I said, just ignore. Like, essentially, the all -4 is just like, yeah, I just like, what I did is just, I didn't just take one timing and applied it to all clocks. I took this, oh, wrong, that's the wrong thing. I took this one and applied it to this. I took this one and applied it to this. I took this one and applied it to this, and I took this one and applied it to this. So yeah, so that's why wrong thing again. So that's why this is at 240 and then like 235. Like, it performs not just very well at high clocks, but also pretty well at low clocks, because I'm running the pretty much tightest possible timings for every clock I have, which is interesting, but kinda pointless, because you're running the highest frequency you can get anyway to get your best scores, and that's exactly the same as this one, because you just end up running this strap at over 1700, and, well, we were running at 1900. So yeah, same thing. So that pretty much concludes the findings here. This is about a good 2 hours of work of just creating custom biases, flashing custom biases, running OCMM bench, pressing the reset button when the card would like crap out, like here or here, because it would be quite mostly spectacular. Like, sometimes OCMM bench would run and then the desktop would start artifacting. Sometimes you would just, like, the moment you apply the clock, the card would just like die. Yeah, in one of the runs, I think it was this one actually. This one briefly ran. I was actually seeing 290. I forgot the unit it's measured in. Is it gigabytes per second? I think it's gigabytes per second. Yeah, I was seeing 290 gigabytes per second bandwidth at this, but then it crashed. I might be able to run that if I take the memory really cold. Like, I was doing this on air. I had a Morpheus heatsink on the card. So yeah, like the memory wasn't getting like any special, like if I ran the card on water, I would have direct airflow over the memory chips. In this test setup, I had airflow through the Morpheus, which is kind of a pretty thick heatsink, to the memory chip. So they did get kind of hot. Cooling them down could help. I haven't tested AFR for cold scaling really. There is a little bit of voltage scaling in it. Like only a little bit, like nowhere near what Samsung does. Like Samsung chips like to usually scale very, very much with voltage. This one doesn't really scale that much, but there is a slight difference. I can't say really anything about cold scaling on these. I have a feeling it either doesn't care or you have to take it like really, really cold for it to matter. So yeah, I'm gonna pretty much say something if I find out something. I was planning to actually run dry ice today, but I didn't end up ordering it because I sort of lost my motivation to work on things midway through the week. And then Friday happened, and now I don't have dry ice. Yeah, like I was planning to do dry ice. I'm probably still gonna do it this month or early next month. It's just like I don't wanna be benching dry ice when I'm not like feeling like it, because that looks like a way to be miserable, because dry ice boils away. And yeah, you have to basically use it the day you get it. So yeah, so I do wanna run it when I'm like happy about it, and not just like I kinda don't really am motivated and stuff. So yeah, like I wanna be motivated when I do things, and I was motivated to do this testing today. And yeah, so result is run this, run the custom 1700 MHz strap. I hope I won't forget to put the custom straps I was running in the description. Again, if I forget to put them in the description, just write a comment, and then I'm either gonna fix it in the description or just write a comment myself with the memory straps. And there's gonna be a tutorial on how to do this mod, because like Bullseye has a tutorial on how to do it, but he did leave out one kinda crucial step, which might be because he just forgot, because it's like basically you do it. If you do anything with like BIOS modding, you always do that, so maybe he just forgot because he's so used to it, or maybe he just assumed everyone would know it. I didn't. I needed some help pulling this mod off, so I guess that's why I'm making the video. So yeah, but that's pretty much it. So yeah, run 1700 custom or just 1375 if you don't want to bother with custom timings. This still does perform very well. So yeah, I hope you enjoyed this spreadsheet video. And until next time, goodbye.